So I rewrote this so that hopefully it'll make a little more sense. Probably saying that I'm multiplying top and bottom is better. So I'm going to multiply the whole fraction by 1 because then I don't change the value of it. And so as you can see, if I do 1 over x times 1 over x, that of course equals 1. But I'm going to be strategic on this bottom one, and that I would like this version of x, since it's positive, to be the square root of x. And if you think about that for a second, you should say, oh yeah, square root of x squared is just x. So those are in fact equivalent. So now I'm going to multiply top and bottom. So the top is getting multiplied by this, and the bottom is getting multiplied by also 1 over x, but in this form. So of course then it's going to look like this. So I'll have x over x from the top, and square root of x squared plus 1, oops, over square root of x squared. And of course I love to simplify, so that top is going to be 1. And that bottom, I can put all inside the radical. I just have to remember that everything is getting divided by x squared. And now I'm ready to start thinking about the limit as x goes to positive infinity. And of course this first piece will be 1, and the second piece says I'm taking 1 and dividing by a quantity that's getting bigger and bigger and bigger and bigger. So this value, this fraction, is getting smaller and smaller and smaller. Essentially it's turning into 0, which would give me 1 over the square root of 1 plus 0, which is 1 over the square root of 1, which is 1. So the limit as x goes to positive infinity is positive 1. Now we need to look at what's happening when it goes to negative infinity. So here's the part where it seems just a little bit crazy, and you have to remember that when I take a square root, it can either be plus or minus. So in order to generate negative values, I need to be working with the negative square root version. And so this time I'm going to divide by 1, I'm going to multiply, by 1 over x over 1 over x. But I want to be strategic in that now my 1 over x is going to be a negative square root. So it's going to look like this. And of course on top I still get 1, and on bottom that negative stays in front of the radical, but I can put the radical contents all together, again keeping in mind that both values are getting divided by x squared. And now I can consider taking the limit as x goes to negative infinity, and this x squared over x squared will still be 1, and this will still be 0. So I'll have 1 over negative 1, which is negative 1. So as x goes to negative infinity, I get negative 1. So again, what's happening on that graph is I'm going to get a horizontal up here at 1 for positive infinity, and a new horizontal down here for negative infinity. So I've talked a little bit about, and to some of you more than others, about what our goal really is, and that's to be able to graph without having to use a graphing calculator. So some things that I need to keep in mind, some very important places that I should find on the graph that we've been talking about in class for the last few sections is number 1, using f of x, of course, I can find my x and y intercepts. Those would be useful when I'm graphing. Then I'd like to find any discontinuities, in case there are any. Remember, that's when your denominator is equal to 0, and they could be wholes or asymptotes. And remember, these are the vertical asymptotes. So if I want to find the horizontals, I'll need to look at the degrees again. And then last, I'll just make an XY table and test values to the left